Hello everyone, welcome to Reactify Labs. Today we will talk about geohashing. Hmm, Geohashing. It's not who, it's hashing. Okay, good. So before we go into what geohashing is and why it is required, let's see where geohashing is used, how important geohashing is. Uh, we will get to know first that what are the different systems that we see in our daily life use geohashing. Then we will be in better position to understand why geohashing better than some other methods. Okay. So geohashing is a very crucial component in all those systems which use maps like Google Maps. Another example would be Uber, things like DoorDash, or for India it's Zomato, Swiggy. So these apps use geohashing. And what do they use geohashing for? To calculate distance between two places. To calculate distance between two places. To calculate the estimated arrival time for your ride or food, right? Also, if you remember seeing things like petrol pumps near me or ATMs near me, so those things also use geohashing. So it is used to find nearby ATMs, shops, restaurants, etc. Right? So these are all the things where geohashing is used. Okay, now I think we have a better understanding of uh, where all geohashing is used and why it is such an important topic for us to study. Okay, now a common question which might arise, actually it should be a curious question. If it is not arising, then obviously somebody is missing something, you are not questioning enough. So the question should come, that is, why do we need geohashing? Like, why geohashing and what this geohashing term is? Why cannot we use latitudes and longitudes, right? For everything we know, obviously, at the base level, everything is latitude and longitude. Let's say it's something is 40.11 degree latitude and 60.22 degree longitude. It is possible, right? We know this position, we know another position xy. We can easily calculate the distance between them, right? You would say this. But it's a wrong assumption or wrong belief that we can do this. Obviously we can do this, but it's not a preferred method or it's not a feasible method also. Why? Because different reasons. First, while these are conventional coordinates, they are easy to represent, conventional coordinates at the base level, but they are not ideal for efficient calculations due to their continuous nature. Due to their continuous nature. So we do not know the precision level, right? It is possible that something can have address like 1 1 1 something something something, So these numbers are like very continuous. They are not discrete that okay, we have something 40, then 41, then 42. No, these things are continuous. So that's why it's difficult for to use latitudes and longitudes here. Okay. Also, if we use them directly, so their direct use leads to complex calculations. Their direct use leads to complex calculations. Okay. Next is why calculate complex calculations? Because it involves complex or intricate. It involves intricate trigonometric formulas. Trigonometric formulas which makes real time calculations computationally intensive. It will make it computationally intensive and time consuming. Okay. So these are the problems with latitudes and longitudes. Remember this point. I'll talk about it in the end also. Okay. Why this is not feasible? Just remember this point. Okay. Next, let me show you how this calculation is carried out. We are talking about how difficult the calculation is, right? Let me just show you a simple example of how it is, how complex it is actually. So what we will do is we will take a very simple example of calculating distance between Los Angeles and New York City. Okay. So we will take one point in Los Angeles and one point in New York City and we will find the distance between them, right? So let's take anything. It is possible that if we take something and something here, the distance will be, what do you say? It may have an error, okay? Not an error actually. Uh, it will be the same distance, right? For any two places, similar distance with an error of maybe 100 to 200 miles, possible. But for the sake of calculation, what we will do is we will use the same coordinate for our calculation and we will compare it with what Google Maps show us. Okay. Then let's calculate it. So for New York City, I am taking a coordinate which is latitude 40.7128 north. Okay. And let me make it like this. NYC lat long. Okay. It is 40.7128 north and minus 74.0060 west. Okay. And let's take a point in Los Angeles which is 34.0522 north and longitude is minus 118.2437 west. Okay. And we will take it Earth's radius, sorry, we will take Earth's radius as almost 6371 kilometers, which is approximately equal to 3959 miles. Okay. So what happens is, first we will convert the latitudes and longitudes into radians. Okay. So we will name it 1 and we will name it 2. So this will be lat 1, lat 2, long 2. So if we convert lat 1 to radians, we just have to multiply it by 150. 180. Okay. and there are some things involved here. So this will come out to be 0.7103 radians. Okay. Similarly, long one is minus 1.2915 radians. Okay, now we have lat 2 as 0.5946 radians and long 2 as minus 2.0631 radians. I think I made a mistake. I said we'll multiply the latitude by 180. It's not. It's like we will multiply the latitude or longitude, whichever it is. We'll multiply it by pi and then divide it by 180, which will give us the radian value. Okay, this is how radian calculation is done. So if you want, you can verify it. Let's do a verification for this, rough verification for this latitude. So it is almost 40 into pi divided by 180. So this is almost 4 into 3.14 divided by 18, which is 12.56 divided by 18, which is almost, if you see, 18 times 6 is 108. Then we have 176. It's almost 18 times 10, 9 actually, 18.99. So it's 0.699, something like this, right? And we have made it 0.71. It's also because we did not take into account this 0.7128, but it will be same for all these. You can verify the calculations. It may be wrong also. I am not sure. I'm just taking an example from the internet. Okay. But it should be correct, I assure you. Now we have these. We will calculate the difference between latitude and longitude. So the latitude difference is, if we subtract lat 2 minus lat 1, we will find out that it is minus 0.1157. And if we find the longitude difference, we will see it is minus 2.0631 minus 1.2915 is minus 0.7716. Okay. Now we have the latitude and longitude distance difference also. Now there is a complex formula involved for finding the distance, which is called, actually from here we went here, from here we went here, now from here we are going here. Okay, now there is a formula called Haversine formula. Okay, and this gives us something called A. There is a variable which is A. We are going to use it later. So A is given by sine squared latitude difference divided by 2 plus cos of latitude 1 times cos of latitude 2 times sine square longitude difference by 2. Okay, and if we put the values of everything, we will find that A becomes 0.0994. Okay, now there is another variable called C, which we will calculate using the formula 2 times A tan 2 of A comma 1 minus A. Okay, and this will, putting the values of everything here, we will find that C is 0.6502. Okay, now we calculate the distance, which is given by r times C, where r is the radius of the earth, which we have taken 6371 kilometers, and if we multiply r and C, we will find out that the distance will come out to be 4140.58 kilometers or 2574.14 miles. Okay, so how would we know if we got this result correct or not? So if you open your Google Maps and you will just insert a query like what is the distance between Los Angeles and North New York, you will find that it is the result that comes out from Google Maps result. It is 2780.2 miles. So if you see, the distance is not very far. It means our calculation is more or less correct. It's hardly 200 miles difference. Okay, so it's not wrong because the Google Maps it will show you the road distance. So the road is calculating the distance. Distance, yes. But the formula that we use from latitude and longitude, we calculate displacement. Okay, road calculates distance, we calculate displacement. So we calculate the straightest route possible. Road has these kinds of paths. So that accounts for the 200 miles error that we are getting here. Okay. So I hope this shows you how intricate this calculation is. Okay. Also, if you notice something here, we will have to do this calculation in real time. Wherever we are, we have to do it in real time. If somebody is have to find the distance between that person's house, okay, and somebody who lives 2 miles away, for that also all these calculations need to be done in real time, and it keeps changing, right? If the person is on move, the person's coordinates keep changing, and depending on that, every second these many calculations are going to be very much for the processor to handle. That's why we prefer not to use this latitude and longitude in calculation. Now that we know what are the what do you say overheads of latitude and longitude calculations, let's see how geohashing solves it. Okay, and before that, let's talk about what is geohashing. So geohashing is a method which converts geographic coordinates this is a method which converts geographic coordinates into simpler and fixed length alphanumeric string. Okay, it converts it into alphanumeric string, providing a structured grid system to represent locations. Providing a structured grid system to represent locations, right? And how does it achieve this? So geohashing divides the world into cells. Okay, it divides the world into cells. Don't worry about these technical definitions, I'll explain in the example also. So it divides the world into cells and encodes each cell with a unique string. It encodes each cell with a unique string. How does it do it? It uses algorithms to convert coordinates to strings. Okay, so it uses algorithms to convert coordinates to strings, allowing for easy retrieval of nearby locations and efficient distance calculations. Efficient distance calculations. So you may ask here, even this is converting coordinates to strings, then how is it better than directly using the coordinates for calculation. It is better because if something has to convert coordinates to strings, then it is fixed. So if we have a coordinate, let's say 40.11, and if it is encoded to a string like xyz abc, it will always be xyz abc. Okay, and whenever we have to use calculations, then we will forget about this and we will only use this. I'll show you later how this eases our calculation. Okay, let's finish this technical definitions for now. Okay, it enables geohashing also enables faster proximity searches. Faster proximity searches. Proximity searches means ATMs near me, shops near me, petrol pumps near me. These are proximity searches, like near a particular location if you have to find something, right? Proximity searches reduces computational complexity, and optimizes database queries, right? So these are the things which are provided by geohashing to us. Let me show you now how it helps. Let's take some examples. First, I'll show you what is the encoding, as I talked about here, that it encodes each cell with a unique string. What is this unique string? Okay, so let's see some examples. Actually, it's database queries. So what are some of the examples? Let's take the example of New York. Okay, it has latitudes and longitudes, right? Let's take example of 40.7128 minus 74.0060. This in geohashing is written as DR5 RU Q7V3GE8. Okay, if you see, it must have 12 characters, 2 4 6 8 and 4 12. Yes, right. I'll show you why I'm giving this example. Next, take the example of a nearby location to something in New York only. New York, different location. Okay, its coordinates are, you'll see from the coordinates that okay, they are nearby. Okay, that's 40.7129 comma minus 74.0059. Okay, when this is encoded in geohashing, it becomes dr5r uq 7v 3g e9. Now you see, since these two places are nearby, as we can see from the coordinates, their strings, geohashing strings, have 11 characters common, right? We can just see that okay, only the last two digits are different, last two characters are different, last one character is different. It means they must be very near. But here, just to find out how near they are or if they are near, we will have to again do all those trigonometric calculations, which is computationally intensive. Okay, let me give you another example. Let's take the example of London. For London, the coordinates are 51.5074 and minus 0.1278. If we encode it, it will give us G C P V J 0 Z K V 9 S 0. If you see, this is drastically different from this, right? Which suggests that obviously they are not nearby. Even the first character is not same. It means they are very, very different from each other, very far away from each other. Okay, so depending on how many character matches, we know that how close or how far they are. If one character matches, if only this one character is different, it means they are very near. Two characters are different, little far. Three, more far. If all are different, very far. Okay, so this is how geohashing helps us, just to find out and how far or how near something is, and reduces the overhead of computationally intensive tasks, right? Okay, next, one more thing. these characters that you see, the length of the characters, it gives you the precision. Let me give you one more example. If we take the example of three places in New York, okay, let's take the example of Central Park in NYC, New York City, Empire State Building, Empire State Building, this is also in NYC, and Times Square. This is also in NYC. Okay, let's note down their latitudes and longitudes. For Central Park, it's 40.7851, comma, minus 73.9683. Right? Here we have 40.7484, comma, minus 73.9857. Next we have 40.7580, comma, minus 73.9855. Okay. Now, as I told you, the length gives the precision. So for this, let's say what is geohash of length 7. So it will be DR5RUQ7. For this, it is DR5RUEV. Here it is DR5RUEH. And geohash of length 5, if we see, it is DR5RU. For this also it is DR5RU. For this also it is DR5RU. So depending on the level of precision we need, we may have to take a call on what the length of geohash should be. If you see, if we had the geohash length 5 for all three locations, we would get that all of them are at one place, right? But only when we go one level deep to 6, we see there is a difference, QEE. But still this tells us that Empire State Building and Times Square are together, which is not the case. They are little different from each other. That's why when we go one level deep, the next character also becomes different, which tells us that okay, how far they are from each other, we get that idea. Okay, but from this we geohash 5, we get to know that okay, they are not very far each other, because they are having the same coordinates, at least for the 5 characters. And from here we know that okay, Central Park may be at a different area than in Empire State Building and Times Square, right? Okay, great. What else is left? There is one more thing about the precision and the length, which I should tell you. So depending on the geohash length, we will see how much area it covers. Okay. So if the geohash length is 12, it means the area that it covers is 3.7 centimeter times 1.9 centimeter. It means when we assign all 12 characters, then at this level of precision we know this address, because you may have seen when you would have shared your location on WhatsApp, you would have noticed that you would have got something like accurate to 15 meters, right? So this gives you an idea of what is the length of geohash they are using. We will see what is this 15 meters later. Okay, so depending on what this length is, geohash length, we know the precision. So if we are using, let's say, 11 length character and only the last bit differs, it means that okay, they are very close. Okay, 11 same, 11 same, and one different, one different. It means they have this level of difference between them at this level. Okay, so next, if it is 11, it is 14.9 centimeter times 14.9 centimeter. Similarly, if we keep going, we will see that for 5, if the geohash length is 5, it means it is 4.9 kilometer times 4.9 kilometer. Then it is what? 5 times 5 kilometer, it means 25 kilometer square. 25 kilometer square, right? So here, if you see, here the five characters are same for these three. It means we are getting an idea that all these are within the same area of 25 kilometers square of each other, right? So similarly, if we go more deep, we will see that for length 4 it is 39.1 kilometer times 19.5 kilometer. Similarly, for length 1 it is 5009.4 kilometer times 4992.6 kilometer. Okay, so this is the area it covers, right? For one, it means if we just take one length of geohash, let's say for US it is, or for California it is, for example, C. If we represent California by only the C, not don't confuse it with California's C. Let's say G, we represent G. So anywhere in California, if that falls in the same square, we will get to know that okay, its geohash of length 1 will also be G. It will start with same character, because if you see here also, they're starting with same character. All the nearby places start with same character. Okay, and just to give you a visual representation of how it works, for example, let's say this is our Earth, right? What we are going to do is we are going to spread this into a rectangle. We will open this up. Okay, so if we open this, I'm opening this up just for simplicity. If we open this up, okay, then we will notice that uh, this area is divided into different areas, okay, like this. Okay, next, each is divided again, each is divided again. Okay, and how many, in how many parts it is divided? Let's say if we have, if a geohash is represented by, geohash represented by characters from A to Z and 0 to 9, then it means it's 26 here and plus 10, it's 36 here. I'm not sure if capital letters are used, so for now let's assume it's 36. So the entire Earth will be first divided into 36 geohashes of length 1. Okay, so it will be A, it will start with B, it will start with C. Next, each will be divided into again 36, right? Each will be divided into again 36. Then for next level of precision, we will again go deep. Next, we will again go deep. So this is how we achieve the precision. Okay, so anything which, let's, for example, let's say this is K. So anything inside this will start with K. Okay, so for example, if this is K, then here, now if this is A, then anything inside A will start with A. A. Then inside A, if we go here, we'll see L. L. So it will keep going inside this, and that's how we achieve that precision. So if you see, when you start Google Maps, you will notice that there is a big map at first, and then it goes on inside each level by level, one by one. So when you try to find something, for example, let's open your map and open something called Michigan. Search Michigan, and then you will realize, you will see an entire big map. Okay, and then it goes deeper, then it starts zooming itself like this, and it goes towards the exact location that you are trying to search for, and that is possible by geohashing only. Okay, so I think I have covered everything about geohashing. Okay, yes, one more thing which I told you about, that I'll come back to that point. It's this point: intricate trigonometric formulas. Okay, so if you see, I think I told you before also. So if the geohash is like this: DR5URQABCD, it's EF, and now it is DR5URQABCDEG. Now you see that, okay, all you have to do here is string comparison, and you will see the difference between them is f minus g, which is g minus f is 1, or f minus g is minus 1, whatever you say. Absolute value is 1, right? So it means they are close, and from the basic calculation we will know that okay, the distance between them may be 1 meter or 2 meter, something like this, right? But for this also we'll have to do the entire this calculation to find out that what is the distance between these two places. Similarly, if we would have a difference of, let's say, these five, you would know that okay, if these five places differ, all we had to do was compare these characters, each character place by place, and then we would know how far these are from each other. So that's how geohashing makes our calculations, complex calculations, very easy to do, and which makes our systems, processors, do more tasks in less time, which makes the latency lower, and gives a good user experience. Okay, so that's it. Thank you for watching. Please remember to like, share, and subscribe. If you liked the video, please give a thumbs up and let me know in comments if I did a good job at this. Thank you for watching, and yeah, I'll see you in the next one.